Okay, so we are working on imaginary and complex numbers in this lesson. We've done a little bit in imaginary and complex numbers when we're just trying to figure out how to take the square root of a negative number. So we're going to review that a little bit. Let's pull up here and kind of review simplifying radicals. We haven't done that for a bit. So remember, if you have a cube root of something, then you're looking for sets of 3 that you can take out of each, the 12, the x squared, and the y to the 4th. Okay, so get going on this here. Okay, so out of what I'm actually going to do with these first is multiply them together. That'll be a little bit easier to simplify them once I have them all together. So I'm going to do y and everything in the radicals, because the root is the same, because I've got the same root here and here, I can multiply everything in here together, which is what I'm going to do. But I'm going to leave that 12 and 24 separate. So, because we're going to have to simplify it back out anyway. So 12 times 24. I have 2 x's here and 5 x's there, so I have x to the 7th. And then I have y to the 4th and y squared, which would be y to the 6th. Remember that with fractional exponents, the cube root of something means, for example, x to the 1/3 is the same thing as the cube root of x. This is where fractional exponents come in handy. So let's break our, so this would be 4 times 3, or 2 times 2 times 3. And then we would have 4 times 6, or 2 times 2 times 2 times 3. So in that, I've got at least a set of 2, so that's going to come to the outside with our existing 2. I only have 2 3s and 2 more 2s, so they're going to stay inside there. So we're going to move that over, and within my, so on the outside, I've got 2 times 2, which would be 4, and I know it's got a 3rd root, and now I know I have left inside 2 times 2 times 3 times 3. So 2 times 2 is 4, 3 times 3 is 9, so 4 times 9 is 36. So I've got that all simplified. Now I just need to deal with this. So since you're taking the 3rd root, you're going to ask yourself, how many times does 3 go into 7? It goes in twice, with 1 left on the outside. And what I'm actually going to do, oh, I can't do that now. Darn it, it won't let me go back. So I'll rewrite it up here. I should have left some space for my variables. We can just stick it out here. So it went in twice with 1 left over. And y to the 6th. 3 can go into 6 twice with none left over. So if we want to write that actually in really correct form, we're going to put our variable in first. And so we would have 4x squared times the cube root of 36xy squared. Good. So now let's go to the second review of that. Review that's 3 plus the square root of 2 squared. Really remember that this means 3 plus the square root of 2 times 3 plus the square root of 2. If you can do FOIL on these, do it. If you need to do vertical, do it. If you need to do box, do it. Whatever method you have of multiplying binomials that works for you 100% of the time. I prefer vertical method. You don't have to use it, but you do need to use something that you understand well. So, square root of 2 times square root of 2, those eliminate each other, you just get 2. 3 times the square root of 2 would be 3 square roots of 2. Now I'm going to scoot down and over. 3 times the square root of 2 is 3 square roots of 2. 3 times 3 is 9. I want you to look at this pattern that you've got going on here, because what's going to happen when we get into complex numbers is a pattern that looks very similar to this. What you're going to do is we're switching out something in here for an I. There's going to be an I existing in this. So you're going to combine the 9 and the 2, and you're going to want to write that number first, okay? So you would have 11 plus 6 times the square root of 2, okay? I want you to remember the way that that looks, because complex numbers, that has something very similar to it. Okay, so given what you know about radicals, what is square root of negative 16? Because I told you for years you couldn't take the square root of a negative number, but of course now you know me to be a bit of a fibber on that. So the square root of 16 is 4, and anytime you have a negative, that means you add an I to the back end of it, because the square root, if we remember from a couple of months ago, square root of negative 1 equals I. Okay, so all you do with square root of negative 16 is you're going to get 4I. Okay? Define imaginary numbers. So imaginary numbers are really just a way that we have to handle those situations where we have to account for that negative number somehow. It accounts for negative square roots, essentially. That's really what it does. Okay? So go ahead and simplify all of the problems on number 3. I don't foresee you having any issues with those. Hit pause and then come back and check your answers. Okay, so for A, you should have gotten 6I. For B, you should get 10I. And for C, we've got to break that down. So that's negative 1, square root of negative 1, square root of 9, square root of 8, which is square root of 4, square root of 2. So square root of 4 is 2, square root of 9 is 3. We change that for 4 and 2. So, and square root of negative 1 is I. So we've got 3 times 2, which is 6I, times the square root of 2. Okay? All right, explain in one sentence why the evaluation of a radical always yields a positive and negative answer. So think about why that is true. When we take the square root of 16, why do we get positive and negative 4? Okay? So square root of 16 equals plus or minus 4. So 4 times 4 equals 16, and by the same turn, negative 4 times negative 4 equals 16. That's why you have to account for the plus minus. Okay? So now let's go into different values of I to some power. So let's start here with I to the 0 power. Anything to the 0 power is always, don't say 0, it is always 1. Okay? I to the first would just be I. I squared, remember, if the square root of negative 1 equals I, and then I square both sides, that cancels out. I squared equals negative 1. This is an important one right here. Hang on. Okay, so then if we're going to multiply that by, now you've got negative 1, back that up. So if I squared equals negative 1, now we've got to take that number and multiply it by I. So what we get is negative I. Okay? Now if we're going to multiply that by I, what is negative times a positive? That would be negative I times I, right? So we know a negative times positive is a negative. But now we have I squared, and we know that I squared equals negative 1. So you've got a negative, negative 1, so that gives us a value of 1. I know that may look confusing to you, but just think about why that is, because there's kind of a pattern that goes on here. Okay? Now you're multiplying that by I. So now 1 times I is just I. Multiplying that by I, you would get I squared, which is negative 1. Okay? Do you see the pattern that's going on here? 1, I, negative 1, negative I. 1, I, negative 1, and I to the 7th would be negative I. Okay, we could follow that all the way out. So there's a definite pattern that goes on there. Sorry, that should be an I. It's not a good I. Okay. So I just want you to think about that pattern. That's not something that would be a test question, but I want you to think about why that pattern works and why it turns out that way, okay? So now when we get, in this section, we're only going to do adding, subtracting, and multiplying. Dividing complex numbers involves something called the conjugate, and we are going to work on that more for Thursdays, Wednesdays and Thursdays notes, as well as graphing complex numbers, which yes, you can do. And actually extremely easy. So for today, we're only doing adding, subtracting, and multiplying. The nice thing about adding and subtracting complex numbers is that you are combining like terms just like you would if you were combining like terms with variables. So if I were to give you 2x plus 5 plus 3x minus 9, you could, of course, easily do that, and you would get 5x minus 4. So now instead of having variables going on, I'm going to switch that to a complex number problem. 2i plus 5 plus 3i minus 9. And you're going to treat it exactly the same way. So 2i plus 3i would be 5i. And 5 minus 9 is negative 4. So I want you to look at the similarities between these two. Okay? All I did was swap out the variable for a complex number. It's done exactly the same way. So you shouldn't have any problem with 6, 7, and 8. I want you to go ahead and do those now. Okay? And then come back and check your work. Okay, so if I'm going to go ahead and solve these out, remember that if you're subtracting anything in parentheses, everything, all the signs in the parentheses flip. So 4i plus 7 minus 3i minus 2, because it would flip both of these signs here. So 4i minus 3i is just I, 7 minus 2 is positive 5. For number 7, same thing again, 6i minus 4 minus 8i plus 3. 6i minus 8i is negative 2i, and negative 4 plus 3 is negative 1. Last one, number 8. This is addition, so we don't really need to do anything different. Combine those two. 13i and 5 minus 1 is positive 4. I'm hoping you're thinking that these are simple, because they really are. And they really don't get a whole lot more complicated than that. Even though some of you I know are thinking that they will. Even though they're called complex numbers, in actuality of using them, they're not that complex. So let's go to page 2. Okay, so now we're going to get into multiplying complex numbers. And like I said, and I've told you this before, you've got to be able to multiply binomials well and be able to do it repetitively without making mistakes. So that would mean using FOIL, box, vertical method, whichever method that you're going to use, okay? So we're going to take the first one. And you're going to see an interesting thing that happens with, and actually I will do this one, all three methods, just to be helpful. Okay, so let's do the first one, FOIL. Most people don't use FOIL, but we'll do that one first. 4 times 2 and 4 times a 5i. So we get 8 plus 4 times 5i would be 20i. And then I need to do negative 3i times 2, which would be negative 6i. Negative 3i times positive 5i would be negative 15i squared. But I want you to think about what that value is. What does I squared equal again? I squared always equals negative 1. So this really now becomes negative 15 times negative 1. So if I am going to simplify that, I've got 8 plus 20i minus 6i plus 15. Now I'm just combining like terms. And I want you want to have it in the form a plus bi. Okay? Your whole numbers first and then your complex numbers. So 8 plus 15 is 23. 20i minus 6i would be 14i. Okay. It's necessary to have that in that order also for our graphing purposes that we'll do next week. Okay? So what normally would have been an interesting I squared term becomes just a straight number term because that I squared equals -1. Sorry about that. Okay. Go ahead on to example. Oh, sorry. I did that FOIL. Now let me do it for you. I'll do this box method to see if we get anything different. So 4 and -3i and 2 and 5i. Okay, so 2 times 4 is 8. 5 times 4i is 20i. -3i times 2 is -6i. -3i times 5i is -15i squared. But again, this changes to -1. So it really does is flips the sign of this. So you get +15. Now you actually have the capacity to combine diagonally. You've got i's here, and you have whole numbers here. So now when we combine those, we would get 23 plus 14i, the same answer we got when we did it by FOIL. Okay, let's do the vertical method so those people don't feel left out. So you would have, what we got going on over here, 4 minus 3i, 4 minus 3i, and 2 plus 5i. No, sorry. Two plus 5i, that's right. Third time doing it, you'd think I remember, but you know it's late, so it's okay. All right, so multiplying up and over, just like you do in regular multiplication, -15i squared and 20i. 2 times -3 is -6i, and 4 times 2 is 8. Add those up. This switches its signs because I squared essentially makes your number the opposite of what it was originally. Okay? So you would also get 23 minus 14i, or excuse me, plus 14i. Okay? So there's 3 different methods for the same problem. Fairly straightforward, but I want you to see what's happening when you get that -15i squared. It's flipping the sign of what originally was there. Okay? So I would like you to go on and try example 2, and then come back and check your work. Okay, so I'm going to check this both ways. I'm going to do vertical first, 7 minus 9i, and 4 minus 6i. So I would get 54i squared. So when I change that, that's going to change this whole thing to a -54. I want you to see where that's going to come from right now. See, that I squared here is going to change this number to the opposite of what it is now. Okay? So, and then we have -42i. Then we're going to go down and over. We would have -36i and +28. So when all is said and done, we have 28 minus 78i minus 54. 28 minus 54 is 26. Sorry, -26 minus 78i. Sorry guys, I had to pause for a moment. Okay, so now we're going to do that same problem again, but I'll do it box method for those of you who prefer box. Okay. And you have down one side 7 minus 9i, 4 minus 6i, so we get 28, -42i, -36i, and 54i squared, which is the equivalent of -54. So, combine the diagonals. 28 minus 54 is negative 26, and negative 36i squared minus 42i squared would give us negative 78i. Okay, same answer we got for the other. Okay, go ahead and do example number 3, and then come back and check your work, please. Okay, so I'll do box first this time. So you got 7 and 2i, and again 7 and 2i because it's 2 plus 2i squared. So you should have 49, 14i, 14i, and 4i squared, which is the same as negative 4. Okay, so when you combine like terms, you would have 49 plus 28i minus 4. Your final simplified answer would be 45 plus 28i. Let's lastly do that one in vertical method. 7 plus 2i, 7 plus 2i. We would have 4i squared, 14i, 14i, and 49. So we get 49 plus 28i plus 4i squared. That flips to a negative 4 plus 28i. So you get 45 plus 28i. Okay? And that's it for the notes for today. Told you this module was not so bad. Sorry, this unit. Okay, so the next set of notes you will see dividing, and we will see graphing. So that's it. See you then.